Well, hello Internet, and welcome to part 2 of my Android development tutorial. In this part of the tutorial series, I decided to get kind of the boring stuff that you need to know out here into one giant tutorial. So we're going to be covering things like understanding the Android activity lifecycle, the Android manifest file, and how to support different languages, and a whole bunch of other different things. But you by no means need to memorize all this stuff. In fact, in the description, I'm basically going to provide you with a cheat sheet you're going to be able to copy and paste from, and of course, everything covered here is going to be covered in all the tutorials afterwards. I just wanted to cover this all at once so that in parts 3, 4, 5, and so forth and so on, we'll be able to just make one app after another. So I'll do my best to make it all interesting, and if you haven't watched the previous parts of this tutorial, I provide a link above to those. So I have a lot to do, so let's get into it. Now, the first thing I'm going to talk about is the life cycle of an Android activity, and I hope from watching the previous tutorial you understand what an activity is. Now, you have to understand, whenever an Android app starts, the Android system constantly calls different methods in an activity that correspond to how the user is interacting with your app. As the app starts, the methods onCreate, onStart, and onResume are going to be called in order. And then once again, whenever your app is shut down, the methods onPaused, onStop, and then finally onDestroyed are normally going to be called. And these methods are going to be needed to avoid things like app crashes, and of course to minimize system resources needs, and also of course to save data entered into the app by the user. Now, aside from resumed, paused, and stopped, every other state documented here is just going to be a temporary state. Resumed, paused, and stopped are going to be states that can occur over an extended period of time, however. So we're going to really focus in on them here for a second. The resumed, or the running state, and whenever I talk about these states, I mean we are currently going to be in these methods, onResume, onStart, onCreate. The resumed or running state, like I said before, is going to stand for the state in which the activity is in the foreground and the user is currently interacting with it. The pause state, or when we are in on pause, is going to stand for the state in which the activity is obscured by another activity, and it won't be able to execute code or interact with the user in any way whenever it is in the on pause method. The onStop method is going to stand for the state in which the activity is in the background. And whenever we're in this method, all data that is being used by the user is going to be retained, but of course, just like before, you're not going to be able to execute any code for that said activity. So now jumping into the Android manifest file, when the user opens up your app, the system calls the onCreate method, and this is an example of the onCreate method, as you can see right here, and this comes from mainActivity.java. So whenever the onCreate method is called for the activity that you're going to define in Android manifest, right here, .xml, and the activity that contains both this intent filter, which you can see right here, which is just another tag, and also has the main action as well as the launcher category, this is going to tell the Android system that this is going to be where we are going to start, or this will be the starting activity for our application. Now, every time an activity is started, the onCreate method is, of course, going to be called. And what onCreate is basically going to do is perform basic startup logic that is only done one time over the course of the activity's lifetime. Then again, whenever your activity is being removed from memory, eventually the onDestroy method is going to be called normally. I'm going to get into in a second why I keep saying normally. Now, the onDestroy method is normally only going to be created if you are using things like threads or you have other long-running resources. And in fact, most of the cleanup is normally going to be handled by these methods, which is going to be onPause and onStop. And as we're going to see later on in the tutorial, you could actually end an activity by calling a method named finish pretty much anytime you'd like. Now, normally an activity is going to be considered paused when it is partially obscured. Let's say a dialog box or something is over top of it. That's what I mean by partially obscured. And whenever an activity is paused, it is very important to release resources that may be needed by whatever the current focused activity may be. So you should release things like the camera, GPS, shut off sound, any video that's playing, end animations, or anything else that may consume resources, and always pay attention to anything that may deplete battery life. And in fact, you may also want to save any data that would be needed if the app was completely closed, which of course, if you ever get to the on pause method, it is very likely that the app could be shut down altogether. However, normally you're going to want to save any data inside of the onStop method so that you don't slow down any transition from one activity to the next by consuming resources to save information. And then once again, whenever an activity is resumed, we would once again provide access to these resources that we shut down whenever we entered the onPause method. So if we were using the camera or GPS or sound or video, we would then provide those resources back to the activity whenever it received focus again. Now, an activity is considered to be in the stopped state whenever it is not visible in any way on your screen. And whenever this occurs, whenever you get to the onStop method, what you should do is release all resources that are absolutely not required. And understand, of course, that if an activity is stopped and system resources are required by the system, that the system will very often kill your application completely, often without even calling the onDestroy method. So you should, like I mentioned before, use the onStop method to complete any CPU-intensive shutdown operations, saving of data, and so forth. Now, whenever an activity is restarted, onRestart is first called, and then immediately thereafter onStart. And you're basically going to put inside of the onRestart method any restorative work that would be needed when you are coming from a stopped state, which, as you can see here, that's exactly what's going on. However, understand that the use of the onRestart actually isn't very common, but it is, however, sometimes needed to once again allocate resources that may have been lost whenever the onStop method was called. And that basically covers the life cycle of any activity that you would create whenever you're creating Android apps. And that brings us to supporting different languages. Now, as we saw before, it's often good practice to store strings in external files. And like we did before, we stored them in a file called strings.xml. And if you don't remember, that was in the resources directory under values. Now, if you want to support different languages, basically all you need to do is create additional folders that are going to have a dash after them, and then they're going to be followed by a country code. And I just listed a couple of the most common country codes here. And down here is a link to many of the different language codes that are available in the world. So rather than me just talking about this, I'm going to show you exactly how to do it. So here we are once again inside of the app that we created last time. And this is what I was referring to, strings.xml. Now, if we're going to want to cover other different languages, it's actually pretty easy. We're just going to go into resource, and we're going to come into this guy and go new, create ourselves a new folder. Right like that. And then inside of here, we're going to go values. So let's say that I wanted to cover Spanish. Well, we're just going to put ES inside of there and hit finish. Then what I'm going to do is open the strings.xml file, which I actually have it open here already. And I'm just going to select everything, copy that. Then down in values.es, again for Spanish, we're going to come up, go new, come down here and click file. And then inside of this, we're just going to go strings.xml, exactly like before, and hit finish. And then inside of it, paste in exactly what we had before. And the only difference is we're going to come in here and change these English words into Spanish words. And magically, I'm just going to come in here and paste that in there. And there you go. That's all you need to do. And this is automatically going to work for Spanish. And of course, you could do exactly the same thing for French or whatever. I'm just picking these randomly. Resources, new, folder. Come in here, type values, -fr, click finish, create a new file, strings.xml, click finish, and then inside of this, paste in your French version of all of your resources. And that's basically all you got to do. Now, if you want to be able to grab these strings, of course, after you have saved them inside of the strings.xml file, what we're going to do here is go into main activity right here. And you can see right here where I'm actually grabbing that based off of ID. So this is grabbing the edit message string. So if we go into strings.xml, here is edit message. And over here, I am grabbing it using its ID. Now, I could also get it, and this is in my actual Java code. Remember, we're in main activity.java. I could also grab these strings. Let's say I want to go string message and save it in here. I could go get resources like that, get string, and then inside of it go r.string.edit message. That's another way to get a hold of it. And I also could assign a string resource to a method. Let's say that I go text view is equal to new text view. this like that. So I just created this resource, and this is mad down here because I already have a message, but either way I'm just showing this for demonstration purposes. If I wanted to pass a resource inside of here, set text, I just go R, once again exactly the same thing, string dot edit message, right like that. So that's how we'd be able to pass it in. So you can see I'm basically using exactly the same thing to pull information out of strings.xml. Now, if I want to actually pull that information out into my XML file, like I do here with my manifest file, you can see a couple examples here how to do that. Here, we're pulling a string out of that strings.xml file by just putting in an @ string / app name. And if we jump over here, we're going to see app name. There it is right there. And if we jump back over into this XML file again, we're going to see there's app name again. And we're going to see here title activity display message. So basically just @ with a string / and the name of whatever the string is named inside of strings.xml. So that's how to pull it in based off of if you're in a Java file or if you're in an XML file. So now to finish off, I'm going to cover the Android manifest.xml file, and I'm going to go over a whole bunch of things and what they mean inside of this file. Again, don't try to memorize this. A link in the description has everything I both say as well as I display here on the screen. So I'm just going to go through here real quickly and explain what this is. I guess I actually should say exactly what the manifest is. Basically what the Android manifest.xml file does is it defines requirements, components, and security for your app. It also talks about services that the app requires and so forth and so on, but we'll get into that at a later point in time. But basically what we're defining here inside of package is just the package name for your app. Then what we're going to have here is the version code, and this is basically just used for whoever developed the application. It's just going to provide an easy way to track app versions as changes are being made. And then here finally is the app version that would be displayed to a user if you'd want to do that. Now the uses SDK is going to define both the minimum as well as the maximum SDK version that's going to be required on a device to be able to run your app. And whenever you're defining this, you should always make sure that you set minimum. Otherwise, it's going to default to 1, which is probably going to cause all kinds of crashes. And the target SDK version should almost always be set to whatever the latest version is. And that is even going to be true if you are not doing anything special with that specific latest API. And there's another one of these tags inside of Uses SDK that allows you to set the maximum SDK, but it's advisable not to even mess around with that. Now, the Uses configuration is going to define hardware and software features that your very specific app is going to require. Now, this is normally not going to be needed because you should aim to have your app work on pretty much any device. However, in those situations in which certain hardware is required, this is how you would do it. So, under this first one right here, required 5-way nav, this is going to be set to true if an input device that is capable of navigating up, down, left, and right is required. Here again, keyboard type is going to be set to true if a keyboard is going to be required to use your app. And then down here you can see exactly the types of keyboards. So if you require a very specific type of keyboard to be available, well, here you would define that. Then if you require a way for the user to navigate using your app, you could also define down here whether you would have undefined, no nav, D-pad, trackballs, or some type of wheel device. And then down here, finally, if you required a very specific type of touchscreen, you would define that either as no touch or a stylus or a finger type touchscreen device. Here inside of the Uses feature tag, you're basically going to define numerous different hardware features that your app requires. And in essence, what you're doing here by using this tag is requesting permission to use this hardware. And I'll provide a link to a whole gigantic list of all the different types of hardware types that you can possibly ever need. If, however, this is really just simply a request and you do not need it, you could just come in here and type required equals false. And that would allow your app to run on devices that do not have or do not give you the permission to use these different hardware features. And here is just another example of how to use the usage feature tag that sometimes confuses people. Let's say that you want to require an absolute minimum OpenGL version. Well, in this situation, what you would do is the first 4 numbers are going to represent 2 and then 0.1. So that is how you would define a very specific type of OpenGL, and this is the minimum requirements that would be needed to use your application. Now, permissions are going to be used to restrict access to certain application components. So here what I'm doing is defining a permission, and I'm going to go through here and step by step explain exactly what all these different attributes mean. The description, as I'm sure you are well aware, is just a description of the permission, and of course it can be provided if a user ever requests it. Icon is going to represent the permission itself. Label is going to be the permission's name that is provided to the user. Name is going to be used if you ever want to refer to this permission inside of your code. Permission group provides a way for you to group permissions. And then finally, protection level is going to define certain risk possibilities that are associated with providing this permission. And just to briefly go over those, normal would be a low risk permission that shouldn't hurt other applications, the system, or the user. Dangerous would be a higher risk permission that could provide access to private user information or could hurt the system in some way. And then signature is a permission that the system grants only if the requesting app has the same certificate as the app that created the permission. Once again, don't try to memorize all this stuff. It's available in the description. Now, a uses permission, just to cover this really quickly, requests access to restricted code or data on the device or something else that could be potentially dangerous. And each of these permissions has a unique label. And if you are asking for one of these potentially dangerous permissions with your app, just understand that at install time, the user is going to be asked if they want to grant you this power or not. And then, of course, based off of how you create your app, whether the user decides to provide this permission or not could either cause your application not to install or fail. And here you can see an example of some type of information you might not want to provide to an app. Now, as you're well aware, Android is obsessive about being able to run on numerous different types of devices. And inside of the support screen tag, you are going to be given the option to specify different screen sizes that your app is going to support. Now, just understand that normally resizing applied by the system for most apps doesn't require you to do pretty much anything for your app to be resized. You're basically going to use this only to define very specific situations in which the way that the system decides to resize your app just plain off don't work. And here basically you're just going to be defining true or false, is your app resizable? Then you're going to be defining true or false, does your app work on screens smaller than HVGA? And in the previous part of the tutorial I talked about those resolutions. By normal screens, we're talking about cell phone screens here, so does your app run on a cell phone? Probably should. By large screens, we're asking, will your app run on a device that falls somewhere between the normal phone size and a tablet? Extra large screens, as you see here, normally refer to tablets. Any density should never be touched. And of course, it's going to be true by default, so just ignore that. And you should also completely ignore requires smallest width DP, just don't even pay any attention to that. And then whenever we get down into this area right here, compatible width limit DP is going to allow you to define the upper bound your app may not work with, while largest width limit DP is going to allow you to define the upper bound in which your app definitely won't work with. And that brings us down into the application nodes, which is actually going to be the last thing that I cover here. Now, there are numerous different attributes that are available using application nodes, and I just have the most common ones listed here. I provide a link to a gigantic list of a whole bunch of them underneath in the description. But basically, I'll just go over these basic guys here right now. By marking allow backup to true, if you so choose to mark allow backup to false, just understand that no backup or restoration of the app will be performed in any way, so this is almost always going to be true. Icon, of course, is going to be a reference to a drawable resource that's going to represent your app's default icon. Label is going to provide a name to the user for your app. And then theme, which we're going to be covering later on in great detail, is going to reference a style resource that's going to represent your theme for your application. Don't worry, we'll get into that later. Again, down here inside of the activity node, which you see here we are, just like I talked about before, going to define using the intent filter right here that as well as main and launcher inside of here, that this is going to be the activity that is going to be loaded by the app when everything basically just starts off. And that is basically a rundown of all the technical sort of things you need to think about, put into the back of your head in regards to making apps. From this day forward, I'm just going to make one app after another in parts 3, 4, 5, 6, 7, and onwards and onwards and onwards. Please leave any questions or comments below. Otherwise, till next time.